potential risks of flying up into the air just in their daily life? Nope, just kidding. They wouldn't really fly up unless they have wings.
So, when will kids fly up into the air? Will it even happen? That's the question to answer, all in terms of physics.
You see, physics have always been happening in their daily life. It is something useful and significant, but also something we don't realize in an explicit way. So, how does conceptual physics come into play? Today, we're here at the park looking for some real physics of the human nature. And now, we'll be talking about how people can fly up in the air based on the concept of torque.
Torque is the rotational version for dynamics, considered to be the amount of tangential net force applied rotationally around an axis. Torque is a quantity vector in which it has both magnitude and direction. And an axis of rotation is an origin on an object where it rotates from. The further the net force applied from the axis, the bigger the torque is. Shut up! Today, we'll use this swing as an example of torque. As Junyu sits down on the
swing,
Aiden is applying some force to his back, causing Junyu to fly up into the air. No, causing Junyu to move in a circular motion. Now, Aiden and Junyu are switching while Junyu pushes Aiden up with a bigger force, causing Aiden to move up in a circular motion with a bigger torque.
Now, when we talk about torque, we also have to talk about rotational motion because they're so closely related. We see rotational motion in our everyday life. Even us as humans on the earth are also rotating without a conscious mind. Now, let's welcome Aiden into the stage. This sort of ungentle movement is considered as one example of rotational motion. Even though Aiden here is applying an external force that almost broke the door, it is a torque that causes the door to move around the vertical axis. Notice that Aiden applied the torque almost at the edge of the door, resulting in a larger torque than when he takes from a smaller distance from the axis of rotation. This calls back to the torque formula that we've talked about in the last one, which is radius times alpha. When the torque is applied at different positions, the door will also accelerate differently.
So, we ended the day with an example of opening the cap from a water bottle. This motion happens every day in our daily life, but did you know this is actually a force of torque? In order to open the cap, you have to apply a rotational force. And torque is a measure of force that causes an object to rotate by its axis. The larger force you use to rotate the cap, the larger torque there is.
But what if there's a larger radius?
Okay, well, if there's a larger radius, then the cap is going to explode to the universe, to the Mars, to the moon, to the...
Oh! Ew!
Okay, sorry. Let's come back. So, according to torque's formula, torque net equals Fr, we know that torque can result in the equal amount if the forces are applied differently with different radius. For two different radiuses, to result in the same amount of torque, you'll have to apply more force to the one with a smaller radius and apply less for the one that has a larger radius. Meaning that it's not true that only larger forces can result in larger torque. Larger radius can also apply larger torque as long as the perpendicular distance is large enough for the smaller force. As you can see, when alpha male Junyu rotates that popsicle at its edge, the cap is easily opened. But when omega male Junyu puts his hand near the cap, the harder it is to open. And that's just how torque works.
Wow! After this long explanation of torque, hope you guys have a good understanding of it and the concepts behind it.
Torque isn't really a hard thing. Once you get the concept of it, you see how fun it is.
Thank you so much!